Right then, lunar enthusiasts, welcome to our deep dive into America's first lunar lander, headed for the Sea of Crises.
Mericresium.
Mericresium, that's right.
Yes.
Now we're using an article from astronomy.com for this one.
Excellent.
And I think, we all know a bit about lunar history, but did you know there was almost like a Soviet-American race to get lunar samples back?
Oh, gosh.
And also, did you know that this plain that looks really desolate could unlock secrets about the moon's volcanic past?
Indeed, Mericresium is a fascinating region.
It is.
Often mistaken, as you say, for just a dark patch on the lunar surface.
Yeah.
It's enormous, actually.
Huge.
It dwarfs Arizona in size.
Wow.
And it's remarkably flat.
Yeah.
And that expanse is composed of dark basaltic plains.
Right.
But within this barrenness, there are signs
right.
of past volcanic activity.
Doug.
Sinuous ridges that meander across the landscape.
I see.
Craters that appear to have been inundated by ancient lava flows.
Right.
And Mons Lettre,
Yeah.
a lone sentinel rising from the plains.
Okay, so that's why this is a good place to go.
Absolutely a prime target for scientific study.
Yeah, and talking of lunar history, the Soviets actually tried to land there
They did.
with the Luna missions.
Yes.
Luna 15 actually crashed into a mountain.
Oh.
Luna 23 landed a bit hard and fell over.
Oh, dear.
However, in 1976, Luna 24 successfully returned lunar samples
What did?
to Earth.
Hmm.
And it really does highlight, the advances in space exploration since then.
Absolutely. And now we've got Firefly Aerospace with
Yeah.
the Blue Ghost lander.
That's right.
And this is part of NASA's Commercial Lunar Payload Services program.
Yeah.
And it marks America's first mission to Mericresium.
It's the first one to go there.
It is.
And it's called Blue Ghost,
Yes.
which is a clever name because...
Well, it's inspired by the Phausis reticulata firefly,
Right.
which just has a bluish-white glow.
Right, so it evokes the image of the spacecraft landing on the lunar surface.
Precisely.
It's a cool name.
It's a key.
So beyond the cool name, though, what can this thing actually do?
Well, it's actually quite compact,
Right.
but it can carry about 150 kilograms,
That's a lot.
which is good because
Yeah.
it means they can carry a range of instruments
All the scientific instruments.
and do technology demonstrations
Right.
that will hopefully lead to some really exciting discoveries.
Groundbreaking discoveries.
Yeah.
The solar panels are pretty good as well, aren't they?
The solar panels are a testament to the advancements in
Yeah.
solar technology.
Right.
They can generate enough power to sustain this mission for up to 60 days.
Wow, so 2 months.
Which means a much longer exploration and data collection period
Yeah.
than previous missions that had shorter lifespans.
So let's talk about the actual journey to the moon.
Yes.
It starts with a multi-week voyage,
It does.
which includes an Earth orbit phase where they test everything
Of course.
before the final leg, which is the lunar orbit phase.
And then the descent sequence is just a remarkable feat of engineering.
Yeah. How does it work?
So the main engine ignites, propelling Blue Ghost towards its landing site.
Yeah.
And it's all guided by the terrain relative navigation system.
So it's making calculations on the way down.
All the time, adjusting its trajectory, making sure it's going to be safe and accurate.
Why?
And as it gets closer to the surface,
Yeah.
it does a pitch-over maneuver,
What's that?
slowing it right down.
To position itself.
Yes.
Okay.
The main engine then cuts off, and 8 reaction control thrusters
8 of them.
take over,
Wow.
guiding the lander down,
For a soft landing.
precisely confirmed by footpad contact sensors.
That's incredible.
It is a complex procedure.
Yeah, I bet. And of course, the lunar surface isn't exactly predictable, is it?
No, it's not. So to reduce the risks,
Yeah.
Firefly have done loads and loads of drop tests on Earth,
Okay.
simulating all kinds of landing conditions. So they've got these shock-absorbing footpads
Right.
that they've tested against all sorts of surfaces.
Like what?
Sand,
Okay.
simulated lunar soil,
Oh, wow.
even concrete,
To make sure it's safe.
to make sure it will be a smooth and safe landing, whatever the terrain.
I see.
And then after touchdown,
Yeah.
the real excitement begins.
Okay, what happens then?
14 days on the lunar surface.
14 days.
Mhm.
So what are they going to do?
Well, the Southwest Research Institute
Yes.
has provided a magnetometer,
A magnetometer.
which is a vital instrument
What does it do?
for understanding the moon's magnetic field
Right.
and the composition of the mantle,
The mantling.
the layer beneath the crust.
I see.
So it will give us really valuable insights into the moon's formation and evolution.
So Texas Tech University have got an instrument on this too, haven't they?
They have got a drill
A drill.
to penetrate the lunar surface
Oh, wow.
and measure heat flow.
And what does that tell us?
this data is critical for understanding the moon's thermal evolution
Right.
and might be able to help us predict future geological activity.
And it's not just those two, is it? There are others?
There are so many.
So many.
Showcasing the collaborative spirit
Yeah.
of space exploration.
Yeah, like the University of Maryland's got that lunar retroreflector.
Yes.
What does that do?
That will allow for really accurate measurements of the Earth-Moon distance.
That's pretty cool.
With implications for all sorts of things.
Like what?
From understanding the lunar interior to probing fundamental questions in physics.
It's incredible, isn't it?
This is just a glimpse of what's planned for Blue Ghost Mission 1.
Yeah.
It's this fantastic symphony of science and technology
Yeah.
that's going to reveal so much.
About the moon?
Yes, and its place in the cosmos.
Brilliant.
Blue Ghost Mission 1 is impressive,
It is.
but Firefly Aerospace aren't stopping there.
No.
They've already got plans for Mission 2
Right.
and even more ambitious endeavors.
Okay.
What they really want to do is land on the far side of the moon.
In 2026.
That's the plan.
Wow. That's
That's going to be more complicated,
yeah.
mainly because of communication challenges.
Yeah, because the far side always faces away from us, doesn't it?
It does.
So there's no direct line of sight.
Which makes communication difficult.
So how are they going to solve that?
Well, they've come up with quite a clever solution.
What is it?
They're going to use the Elytra Dark transfer vehicle
Right.
that will not only deliver Blue Ghost to the far side,
Right.
but it will also deploy Europe's Lunar Pathfinder satellite,
Okay.
which will act as a communication relay,
I see.
making sure there's continuous contact between the lander and Earth.
So it's a partnership, really.
It is.
Elytra Dark taking it there and then Lunar Pathfinder helping to communicate.
Precisely.
So what science are they planning to do?
Well, one of the key instruments for Mission 2 is an Australian-built seismometer.
A seismometer.
Yes.
To study what?
The moon's internal structure and seismic activity in a
Right.
region that hasn't really been explored in this way before.
Wow. So it will add
Massively.
to our understanding of how the moon formed and evolved.
Absolutely.
So seismic data from the far side. That's amazing.
It is. It opens up all sorts of possibilities.
For lunar science.
Yes. Are there any other experiments planned?
For Mission 2.
Well, NASA are contributing an astrophysics experiment,
What will that involve?
which will take advantage of the unique radio silence of the far side.
Okay.
So shielded from Earth's radio interference. It's an ideal place to make observations
Of
of our early universe, which could unlock secrets about how the cosmos began.
That is amazing. It's interesting, isn't it, how the challenges lead to innovation.
It is.
And often they have implications beyond the mission itself.
Absolutely. The technology that's developed
Yeah.
for these missions
Yeah.
often has effects across lots of different fields.
Right, like
Developing new materials,
Yeah.
propulsion systems,
Mhm.
refining communication technologies.
Yeah.
It all impacts us back here on Earth.
Yeah, it's easy to forget that sometimes, isn't it?
It is, but we are surrounded by advancements that came about from space exploration.
In our daily lives.
From satellite navigation to medical imaging,
Yeah.
new materials,
Yeah.
renewable energy technologies.
Right. And now we've got private companies involved.
Yes.
Like Firefly.
Like Firefly,
Stuff-
accelerating the pace of innovation,
Yeah.
pushing the boundaries of what's possible.
And its impact on technology.
Absolutely.
So it really is an exciting time
It is.
to be following lunar exploration.
Yes, with each mission we learn more,
Yeah.
our understanding expands,
Yeah.
and we move further into the cosmos.
It's fantastic, isn't it?
It is a testament to human curiosity,
Yeah.
our drive to explore the unknown.
And the moon, which once seemed so distant,
Yes.
it's now tangible frontier.
Is.
And we're only just starting to understand its secrets.
We are.
And as we
Explore.
the lunar surface,
Absolutely.
I think it gives us a new appreciation for
Where-
where we are
Yes.
in this vast universe.
It's a humbling realization
It is.
that we are not just explorers,
No.
but stewards of this incredible place, our
Yeah.
celestial neighborhood.
And the future of lunar exploration is,
Full of possibilities.
it's exciting, isn't it?
Will we see a permanent presence?
Will we,
get a new?
will we unlock the secrets of its resources?
Will we harness those resources for the good of humanity?
It's amazing just thinking about it.
Lunar exploration embodies the spirit of scientific inquiry,
yeah.
technological innovation,
Mm,
international collaboration.
it does. It's a journey into the unknown.
It is.
And it's driven by our desire for knowledge
yes,
and pushing the boundaries.
of human achievement.
Yeah. And as we move into this new era, with private companies playing a bigger role,
Yes.
what do you think the future holds for international collaboration?
It's a very important question.
It is.
And one that needs careful consideration
Yeah.
as access to space becomes more democratic,
Yeah.
with lower launch costs
Right.
and easier technology.
Yeah.
We can expect to see a lot more activity
Yeah.
from a wider range of players.
Yeah.
So in this new landscape,
No.
international collaboration will be more important than ever.
Okay.
We need to have clear framework
For cooperation.
cooperation,
Yes.
for sharing data,
Right.
for how we're going to use resources, and how we're going to develop this lunar environment peacefully and sustainably.
It's a delicate balance, isn't it?
It is.
We've got to encourage innovation and exploration,
Yes.
but make sure our activities on the moon are conducted responsibly.
And ethically.
Yeah, with that focus on long-term sustainability.
Yes.
For everyone.
For all humankind.
Absolutely.
It can't be driven just by curiosity
Right.
or technological ambition.
Right.
It has to be guided by responsibility
To the planet.
to
Our species. Our species.
future generations.
Future generations.
Yeah, so Blue Ghost Mission 1,
Yes,
it really does set a precedent
it does.
for this new era of lunar exploration. It is a testament to what we can achieve through international collaboration,
Yeah.
scientific ingenuity,
Mm-hmm.
and a shared passion for pushing the boundary
Of what we know.
of human knowledge.
And as we look ahead to Mission 2 and beyond,
Yes,
the future of lunar exploration seems very bright.
it does.
It does.
Full of new discoveries,
Yeah.
technological advancements, and a deeper understanding of our place in this
Cosmos.
cosmos.
Well, as we come to the end of our deep dive into Blue Ghost Mission 1,
Yes,
I think it's clear that we're at a really important moment in lunar exploration.
I agree.
From those Soviet Luna missions
Yeah.
to this cutting-edge technology of Firefly's Blue Ghost.
It's incredible.
We've really, looked across the whole landscape of lunar exploration. It is exhilarating to see all of